Hello, so this is a recording regarding sample problem about projectile motion. So this is one of the challenging problems na binigay ko na example dun sa PowerPoint natin. So let me read the problem. During a storm, a car traveling on a level horizontal road comes upon a bridge that has washed out. The driver must get to the other side. So he decides to try leaping the river with his car. The side of the car is on is 21.3 meters above the river, while the opposite side is only 1.8 above the river. The river itself is a raging torrent, 48 meters wide. So, dalawang question natin. Letter A, how fast should the car be traveling at the time it leaves the road in order just to clear the river and land safely on the opposite side? And B, what is the speed of the car just before it lands on the other side? So, tingnan natin. So, trinay kong i-drawing. So, yung analyze muna natin yung problem. So, dito, makikita natin the car is trying to navigate to the other side. This is the side and this is the side and this is the other side. So makikita natin na naputol yung bridge dahil daw sa storm. So kailangan makatawid yung car. So however, kailangan nating malaman gaano kabilis dapat yung initial velocity ng car para makatawid siya, hindi siya mahulog doon sa river. So medyo silly yung question pero it can happen, no? And kung nanonood kayo ng sci-fi, madalas nangyayari yan. So, kailangan merong initial velocity para makarating ka dun sa other side. However, makikita natin this is an example of a problem na yung object is moving without angle. So, the initial velocity is just in the horizontal direction. So, given yung displacement on one side, itong displacement na to, no, with 21.3 meters relative to the river, and ito yung other side, 1.8 meters relative to the river. So, makikita natin yan. Then, given yung length ng river or width, so yung kapal ng river is 48 meters. So, kailangan hindi siya mahulog dun sa river. So, yung mga given natin for this problem, meron tayong displacement. Yung unang displacement, ito, 21.3 meters. And yung displacement 2, yung height number 2 is 1.8. Para alam natin yung displacement coming from the side to the other side. So, difference lang yun ng dalawang displacement. So, alam din natin yung range or yung layo, no? Yung delta x, ito yung delta x. So, yung hanapin natin, kailangan natin malaman yung initial velocity. And kailangan nating malaman din yung final velocity na kailangan. So, yung initial velocity na kailangan lang natin is on the x-axis since horizontal direction lang yung movement natin. So, parang ganito yung mayayari. May initial velocity dito, then hopefully it will land on the other side. So, makaka-land siya doon kapag okay yung initial velocity niya. Okay, so alam natin yung range, pero hindi natin alam yung time. So, pag dun sa time, ano yung saan natin pwedeng kunin sa x direction or sa x component o sa y component. So, try to think about it. So, we're finding the time. Meron tayong range, pero wala tayong initial velocity and wala tayong time. So, saan natin siya pwedeng kunin? So we can get that on the y component. So pwede natin kunin by finding the y component. We can find time using the y component ng mga formula. Okay. Kagaya ng sinabi ko, you don't need na parang kapag nakita mo yung problem, alam mo na agad yung sagot. So I always tell you na you try. You try, kung hindi mo pa maiisip, parang wag kang mag-overthink. Just try to manipulate the equation kasi meron na naman tayong 4 na equation for projectile motion. So, we are trying to find the time. Kung yung first equation yung gagamitin natin, so naalala nyo pa ba yung mga equation? So, we have negative g is equals to the change in velocity or equals siya sa final velocity on the y minus the initial velocity on the y over time. Kaso hindi natin alam pa yung final velocity, hindi natin alam yung initial velocity. So y, so hindi natin to pwedeng gamitin. So, hanapin natin yung isa pang equation natin. We have the displacement equal siya sa initial velocity, and so y times time plus 1/2 times negative g times t squared. So dito, hindi natin alam yung time, pero alam natin yung displacement, alam natin yung acceleration due to gravity, and alam natin that the initial velocity on the y is 0. So, do you think pwede natin itong gamitin? Yes, pwede natin yung gamitin. So, the third equation, hindi natin pwedeng gamitin kasi wala pa tayong value ng final velocity, wala pa tayong value ng time. Alam lang natin yung height o yung total displacement. Lagyan ko ito ng T para hindi kayo malito kung anong displacement yung hanapin. So, imagine niyo ito yung total displacement. So, simula dito, sa height na to, hanggang dito, sa height ng other side. So, ito yung delta y natin. Ito yung delta y natin. So, yan yung delta y. So, yung taas nito. Okay? Yun yung delta y. Ayan. Delta y. So, alam natin, makukuha natin yung time. No? So, we can manipulate the time. So, let's try to find out. So, find the POX. No? Hinahanap natin ito. Okay. Let's find the time first. So, we use the second equation. So, the total time is equals to initial velocity on the y times time plus 1/2 times negative g times t squared. So, this one is 0. So, yung matitira na lang natin is the total displacement. It's equals to 1/2 times negative g times t squared. So, we can just manipulate it. So, we can segregate na time lang yung matitira doon sa isang side. So, we can equate it na yung t squared is equals to the twice displacement, total displacement on the y over negative g. So, para makuha natin yung time, kunin natin yung square root on both sides. P is equals to the square root of twice the displacement on the y component, total displacement, over negative g. Okay, I'll give you a few seconds to try to manipulate your calculators, or you can write so that you can practice. So, para active learning tayo. No? I'll give you siguro mga few seconds to do that. Okay, na-try nyo na ba na i-solve? So, yung time, equal siya sa square root nung twice the total displacement. So, paano natin makukuha yung total displacement? Kunin lang natin yung difference ng dalawa. So, yung total delta y is equals to 21.3 meters minus 1.8 meters. So, yung total displacement ay 19.5 meters. So, ibig sabihin yung layo nung side, itong height nito, papunta dito sa other side is 19.5 meters. So, yun yung gagamitan natin. It's 19.5 meters. So, it's negative kasi coming from the initial position to final position, no, 1.8 minus 21.3 meters. So, i-ano natin. So, it should be the positive. Yan. So, 1.8 kasi ito yung final position. Ito yung initial position. So, pag ginawa natin yung long cut, no, pag hindi natin shortcut yung solution, we can get the total displacement. So, it's 1.8 meters minus 21.3 meters. So, yung total displacement equal siya sa negative 18.5 meters. Makuha natin yung time over negative 9.8 meters per second squared. So, yung time natin will equal to 1.994 seconds. So, for now, apat na sig figs muna. So, okay lang yun sa final answer natin. I-finalize yung significant figure since we have a lot of operation. So, alam na natin yung time. Now, pwede na ba nating makuha yung initial velocity on the x-axis? Yes, pwede na natin makuha. No? Alam na natin yung time. So, to get the initial velocity on x-axis, we know that the range or the delta x is equals to the initial velocity on the x times time. So, alam natin yung time, alam natin yung range. Ito yung river, di ba? With no river. So, alam natin yung kailangan natin na initial velocity. Yung initial velocity na to, ito yung magkakos para makarating ka dun sa kabilang side. Makaka-affect yun. Okay, so let's find out. So, pag minanipulate natin the initial velocity is equals to the displacement over the time. So, alam natin na yung displacement natin or yung with no river is 48 meters over 1.994 seconds. So, kailangan natin initial velocity ay try to manipulate on your calculators. So, yung makuha natin is 24.072 or pwede natin kunin ilang figures to. So, puro measured value, no? Measured value meters, measured value meters, measured value, walang given na velocity. So, we decide na kapag lahat ay measured, so lahat sila is infinite number of significant figures. So we decide na tatlong significant figures. So it's 24.1 meters per second. Okay, so now let's find the final velocity. So talking about the final velocity, so we know na itong final velocity, meron tayong final velocity on the x and meron tayong final velocity on the y. However, the final velocity on the x, alam natin that it's also the same as the initial velocity. Pero alam natin na yung final velocity nun, parehas meron yung x and y. Meron siya sa x, meron siya sa y. However, hindi pa natin alam yung final velocity on the y-axis. So how can we get that? Siyempre, gagamitin ulit natin yung mga formula for the y component, no? And we know the initial value, we know the time, we know the acceleration. So we can use, pwede natin gamitin yung first equation. Since alam natin na walang initial velocity, pwede ito yung gamitin natin. Pwede rin natin gamitin kung gusto nyo mag-solve. Pwede gamitin nyo yung displacement is equals to the squared value of the y component minus the squared value of the initial component on the y over twice the negative g. So, maalin yung gamitin nyo. So, you can try that. So, ako, gamitin ko na lang to para mas mabilis and mas madali. And okay lang kung ano yung equation na gusto nyo gamitin kasi pare-parehas lang naman yan ang pupuntahan. So, sige, hanapin natin yung y component ng final velocity. So, we can know that using the first equation, we have the final velocity is equals to the product of the negative g times the time. So, makukuha natin yung final velocity on the y as negative 9.8 meters per second multiplied to the time. So, ilang seconds tayo? 1.994 seconds. So, the final velocity that we can get is negative 19.54 meters per second. So, meron na tayong final velocity sa y, meron tayong initial velocity sa x na 24.1 meters per second. So, we can get the final velocity using the Pythagorean. The final velocity is equals to the squared value of the final velocity on the x-axis plus the final velocity on the y-axis squared value. So we can get the final velocity as square root of 24.1 squared plus negative 19.54 or 19.5 meters per second squared. So the final velocity is equals to 31.0 meters per second. So pag land niya doon, yung magnitude ng final velocity is 31.0 meters per second. So, hindi naman tinanong yung angle, pero for this video, isolve na rin natin. So, hindi naman kailangan, pero para lang alam nyo, paano kukunin yung angle. So, alam natin yung x component is 24.1. Ganyan yung itsura nun. It's the VOX. Then, the y component is negative 19.5. So, medyo maiksi siya ng konti. So, ganyan. So, most probably, yung final velocity natin is mga dito, ganito yung itsura niya. So, hindi natin alam kung anong angle nito. So, yung angle equal siya sa, arctangent nung y component over the x component 'no. Equal siya sa negative 38.97 degrees or puwedeng sabihin natin na negative 39.0 degrees. So, makikita niyo mas maliit yung angle na ang opposite ay yung y-axis since mas maliit yung y component. So, you can get na tama yung angle mo. So, kapag puwedeng sagot mo negative 39 degrees or puwede mo ring sabihin na negative 39.0 degrees south of east. Okey lang 'yun. So, ayan, ito yung answer natin for the crossing the river problem.